Good, awesome. So still fusion welding, but we went from fusion welding using an arc, and there are so many ways. That's pretty much all we do in this province, to fusion welding using a beam. And we discuss how we do a little bit of laser clamping in this province, and a tiny bit of laser welding and a tiny bit of electron beam welding. And now I want to shift into another method for causing fusion weld, and in this fusion welding, and in this case, the energy is not from an arc and it's not from a beam, but the energy comes from the heat generated by electrical resistance in the workpiece. Let's get my pointer here. Okay, resistance spot welding. Resistance spot welding is the way you weld cars. It's essential to weld cars. And here we have another artistic sketch. And what do you see here? You get to see the two metal sheets. The typical configuration for resistance spot welding is lap welding. And actually, everybody says typical. I'm yet to see any other configuration for resistance spot welding. And this is a reason. You put a sheet, you put the other sheet, and then you press it, and you're gonna see in the video, with two electrodes that look like copper fingers. And these two electrodes are water cooled, and they put pressure. Now, you circulate a current from one electrode to the other. And you circulate current that is many thousands of amps, very heavy current. And the very interesting thing is that for a given current, the amount of energy generated is proportional to the resistance that it encounters. So the electrodes are made out of copper, so they have relatively low resistance. The metal sheets are continuous, have relatively little resistance, but the contact point between the two sheets, that has resistance. So in resistance spot welding, you have the electrodes on the surface of the sheets, but you start melting at the interface. You create this nugget in between the two sheets. And now the whole art is how to put enough juice, how to put enough power, such that we create a nugget, we melt something, but we should not put so much power that we melt all through the sheets and we create a hole instead of a weld. And that's the name of the game. Sounds kind of easy. Now it's like getting a guitar for Christmas. You get a guitar, now you have to learn to play. And this thing is true. You can get a spot welder, you have to know how to do it. This is a process that drove Elon Musk crazy when they were trying to ramp up production of the Tesla Model 3. So I want to discuss all together these associated processes because they're more or less the same thing. This is called projection welding. And in many aspects it's the same. You have one electrode on one side, you have the two sheets, one electrode on each side. But now the difference is in projection welding, you put like a little bump into one of the sheets. So when the two sheets touch, they touch at that one bump. And when you circulate the current, it's going to melt right at the bump. Right? And this is a common way of welding small things made out of sheet metal, like white goods, right? Like dishwashers or things like those, right? Not common in cars. The finished weld looks more or less the same because by the action of pressure and the plastic deformation, this goes to flat. You're gonna see this in the video that follows. The other type of very associated resistance welding process is called resistance seam electric welding. And now, instead of having the two electrodes that are like two fingers, you have these electrodes that are wheels, look like pizza cutters, exactly like pizza cutters, but made out of copper. So the current circulates and creates a nugget, and as you move the part, you end up having a seam instead of just a spot. Very much the same. So, some characteristics of these processes. Protection of the melt, none, because as we have discussed also before, when I melt the nugget and then I put pressure, I squirt out all the impurities out of the nugget, and I end up with a very good weld. So this is very practical because in car manufacturing, you don't want to be stopping and cleaning every time the sheets. Actually, you don't even want to clean the electrodes. You just want to go and never stop. And resistance spot welding is very good for this. Filler material, none. Of course, all these things you could possibly do it, but you don't use it. Polarity, you typically run resistance spot welding in AC at 60 Hertz. And the reason is the currents are so high that people don't want to put anything funny in the circuit there. They just want a transformer that brings up the current very high without touching the frequency, without rectifying, without doing anything else. Characteristics, very low cost per weld. Each spot weld in a car is a matter of cents. And it's so cheap that it's cheaper to make an extra weld than to do an inspection. So in cars, you have there are many thousands of welds, 3,000 or 5,000 welds, but you are okay with half as many welds. The reason you have so many welds is because in case something didn't go right, you put so many welds in excess, you should be fine. This is in much contrast with our life here in the province, in which you inspect things very much. You don't want a pressure vessel to go boom, right? In nuclear industry, it's all about inspection. Cars, forget it, just weld more, weld more. Resistance spot welding needs very expensive equipment because something that can handle many thousands of amps requires huge copper buses, requires very heavy circuits. And in addition, you have a significant mechanical action in getting these clamps to pinch the sheets and then to put enough pressure to create a little bit of plastic deformation and squirt out the nugget. So equipment is expensive. Works awesome with steel. Normal steel, galvanized steel, it's always good. With aluminum, it's tricky. It's not impossible, but it's tricky. Why? Aluminum has low electrical resistance, kind of not convenient for welding, banking on the resistance of the material. The oxides in aluminum, yes, thank you. Oxides, exactly. The oxides are very difficult to dislodge. And also, aluminum often reacts with the electrodes. Copper and aluminum are good friends, which is not a good thing when you don't want them to have mixed, because if you contaminate your electrode with aluminum, the next contact would be, instead of being copper to aluminum, would be aluminum left over with new aluminum, and you'd have another layer of resistance that can start to perpetuate the problem. You can clean the electrodes, but as I mentioned to you, in the auto industry, they just want to go and never stop. Cleaning the electrode is stopping. It's a very different animal of what we do here in Alberta. So in this case, you need to stop and clean the electrodes often. And if they wear out, in addition of the time that you spend cleaning them, you have to spend time changing the electrodes. That's the reason Tesla Model 3 is made out of steel, is spot welded. Was difficult to figure out, but now that they figure it out, now they're going crazy. It's fine. Model S or Model X are made out of aluminum, and they're pretty much handcrafted, and they are not spot welded. They are MIG welded, right? Welding plays a huge role in the feasibility of manufacturing of cars. You can join more than one sheet at a time. You can put 3. You can even put more, right? But typically you have 2, sometimes 3 in the automotive industry. No problems with position. In this case, unlike all the other fusion welding processes in which position matters, in this case, overhead, flat is all the same. Nobody cares about position for resistance spot welding. You can do it manually too, and you have like little pliers for that. And we have a set of those in our lab that makes tiny, tiny, tiny spot welds. I have done this myself, and it's a lot of fun to do it. Very easy to automate. The welds tend to be relatively low quality. The cooling rate is so fast. You always end up with martensite. Okay, and everything made out of sheet. Automotive for sure, but HVAC, white goods, small appliances. I think this is a good slide to stop. And we have now it's a 9-minute break until Alejandro has a demo that he has made about all the processes with consumable electrodes. So I'm gonna stop here, and I'll see you in a few minutes. Thanks, everybody.